Hey all, so today we're going to go over 12.3 geometric sequences and series. And so the first formula that we're looking at is just the geometric sequence formula. So you can plug this in to figure out any term, to generate a formula, and then what we need to know is that R is the common ratio between each number in the list. And how you find R is the second term divided by the first term. So in example A, we want to find the nth term of the geometric sequence. So first we want to find write down what we know. So A sub 1, the first term, is 10. And then the ratio. So ratio is the second term divided by the first term. So the second term is 9 and the first term is 10. So R equals 9/10. So we're just going to plug that into the formula. A sub n equals the first term times R to the n minus 1 power. Or A sub n equals 10 times 9/10 to the n minus 1. So now we're going to take that formula for part B and find the 9th term. So we'll take 10 times 9/10 to the n minus 1 and plug in 9. So A sub 9 equals 10 times 9/10 to the 9 minus 1. You get 10 to the 9/10 to the 8th power, which if we put this in our calculator, we get that it equals 4.3046721. Okay, next we are going to find the recursive formula for the sequence, and to do that we need to know the first term and the ratio, how you're going between the terms. So for our first term, E equals 10, and our ratio is 9/10. So to find the next term, you always take the term before, so A to the n minus 1. That's our term before, the one we are looking for, and then multiply it by that ratio, so 9/10. And that gives us, if we plug in any term for the recursive formula. Okay, next we are going to look at how to find the sum of a geometric sequence. And we have this formula here. And so we went over what R is, we know what N is, and A sub 1. So let's use that. So let's write down what we have. Right now we're just given a formula. So let's go find what the first term, second term, and everything is. So the first term would be 1/2 to the 1 power, which equals 1/2. The second would be 1/2 to the second, which is 1/4. And then to the third, 1/2 to the third is 1/8, and so on. So we could say 1/2 plus 1/4 plus 1/8 plus so on plus 1/2 to the n power. So we know A sub 1 equals 1/2. And then let's find the ratio. Remember, the ratio is the second term divided by the first term. So 1/4 divided by 1/2. Flip it and multiply by the reciprocal. So this equals 1/4 times 2/1, which equals 2/4, which equals 1/2. So the ratio is 1/2. We're going to take that and plug it into this formula up here. So S sub n equals 1/2 times 1 minus 1/2 to the n over 1 minus 1/2. In the denominator, 1 minus 1/2 is 1/2. So 1 minus 1/2 to the n over 1/2. 1/2 divided by 1/2 cancels. So we're left with S sub n equals 1 minus 1/2 to the n power. Next, we are looking at the sum of infinite geometric series, and this goes by this formula here. And when we're doing these, we want to know if they converge to a number or diverge. And so if it converges, that means it's actually going to add up to something, like get really close, kind of like how an asymptote, how you get really close to it, but you never actually touch it. So that's kind of what the converge means. Because see how we're adding up to infinity. So the new thing is here to tell if it converges is when you find the ratio, if the absolute value of it is less than 1, then the series converges, and this is how you would find the sum. So let's take this first example and find out what if it converges or diverges, and then if it is converged, find the sum. So first, let's find that ratio. So second term divided by the first term, and we can make that 4/3 times 2/1, which equals that would be times 1/2, because that's, and then this equals 4/6, which simplifies to 2/3, and the absolute value of that is 2/3, and 2/3 is less than 1. So we know that this converges. So now let's find the sum. I'm going to make that smaller. So we're going to plug it into this formula here to find the sum. So S equals the first term, 2/1 minus 2/3. This equals 2/1/3, which equals 6. So the sum would be 6. Now let's look at this repeating decimal of 0.999. And we want to know, does it equal 1? So we're going to go and rewrite this as, we can also say 0.99999 forever. Can also be written as 0.9 plus 0.09 plus 0.009 plus 0.0009, and so on forever. You can rewrite 0.9 as 9/10. That gives us our first term. And you can rewrite 0.09 as 9/100. So now we have our first term and second term where we're able to find the ratio. So we will do 9/100 divided by 9/10, and we will get 1/10. So R equals 1/10. And then now let's find the sum, because 1/10 is less than 1, so that means that this converges. So let's see what it converges to by finding the sum. So A(1) is 9/10. So S equals 9/10 divided by 1 minus 1/10. 1 minus 1/10 is 9/10. And then 9/10 divided by 9/10 is 1. So this proves or shows that the repeating decimal of 0.99999 forever equals 1. Please let me know if you have any questions.